Hey everyone! So today I am relocating my web server to new providers, and probably I'm not going to end up keeping my web page the way that it is. It's kind of full of really old projects, a lot of stuff that I don't need to have there anymore. And so I thought maybe what I would do is just make a video about what I have there and then maybe just delete it and start from scratch. And that way I can always go back and look at things that I've created in the past. And this is my page. I was very proud of it at the time. It's got sort of my YouTube name at the top and some background graphics, and I was very impressed with myself at the time that it had a bit of a dynamic layout. It looked quite good on a mobile phone. Not sure why that was important to me because it only really works on a desktop browser for the most part. All of these tiles here were generated by a PHP script that I wrote, and that instilled in me a hate for PHP, which is visceral to this very day. I will never look at that code again or any other PHP. It's awful. Why the dollar sign? Anyway. So the first project on here is a compiler. It's basically a compiler for the game Exapunks. I made a whole video about it, so I won't go into too much detail here. The next thing is a sculpture I made out of pine, which is not a very good wood for carving. But I was very excited at the time because I got some pneumatic tools for my air compressor. And this was made mostly with just 1 or 2 carbide burrs, which is just so much fun to sculpt with. If it wasn't pine, I'm sure I would have been able to achieve a much more crisp design. And I found actually that if you blowtorch a sculpture like this, it makes things like the suckers on the tentacles stick out really nicely. And then I varnished it and mounted it on a piece of Jarrah, nice hardwood. Here's a project that doesn't work anymore. It is supposed to make a nice wobbly sound when these particles wobble, and I wish I could demo it for you, but the something about JavaScript and the way the request animation frame API works. Hey there, it's Nick from the future. I went back and I fixed this one. There we go, that's pretty much what it was meant to do. So it actually has an audio synthesizer hooked up to each of the springs, and there's just a bit of noise that gets generated when each node is dragged along the ground, so you get this. I'm not sure how loud that's going to be for you. Okay, let's never speak of it again. This was just a quick coding project to make a renderer in text. I don't know why I thought to do that. Oh, here's another thing that maybe I should keep. I think this is the best resistor calculator on the internet. So you can click the colors and you get the ohms on the output. I think it's really awesome because even if you don't click on the colors, you can still kind of read it out. And the way that it scrolls up and down to sort of line everything up in the middle, chef's kiss. I've not seen anyone's resistor calculator better than that. This thing here, we'll need to find a picture. Okay, so theoretically, we can paste an image like that. And then there are these 2 squares here, which you can sort of use to measure either area or distance. So what we can do is move this blue line so that it's roughly overlapping the Eiffel Tower, and you can zoom in and out and pan and stuff, although it's a little bit glitchy. Now let's say, given the height of the Eiffel Tower is 330 meters to the tip, so we put that into the little driver thingy here. And now, wherever we move this purple line, provided we're talking about points that are on the plane of that blue line, we can get a reasonable estimate of other stuff. So we can measure, for instance, the width of the base of the tower, and we can see that that comes out to be about 128 meters. And if I go in Google, 124. So we are dead on within 4 meters. That's like the width of the room that I'm sitting in. That's pretty amazing. Yeah, so this is a very useful project if you have a specific use case for it. I no longer need it. I'm not interested in maintaining it, and it's pretty glitchy, as you can see. So I think this one, we're just gonna hold on to this video and love it, and moving on. Next, I have another 3D scan of a beanie. Very bored one day in a motel for work, far from home, and it was winter time, and I had this beautiful bright pink beanie, which I like to wear. I wish I still had it. It was an awesome beanie. And when I found out that you could just take like a bunch of pictures of something and then turn it into a 3D model, I was like, right, I got to try that immediately. And so you can see my red scarf there, and then underneath the horrible drab putrid colors of the motel bed sheets. Yeah, good fun. I really enjoyed that. Okay, what else have we got here? So here's an idea that's been done to death. It's a basic Tetris implementation, but it wobbles when you move blocks around. I don't know why. How do I rotate? Rotate? No? Yes? Okay, we did it. Okay, now we're screwed. There we go. Okay, there's nothing special about this. The weight of the blocks just drags it down. Let's fill it up, and yep, indeed, the weight of the blocks holds it down. I don't know why. I thought that would be cool, but there you go. Wobbly Tetris. Moving along. Here's an earlier version of Photoscaler, which appears to be broken. Let's move on. There we go. Dr. Nick's MIDI surgeon. So, fun fact, I was going to call this the MIDI fiddler, but then I changed that name after just a moment thinking about it. So it's got a MIDI file uploaded to it by the look of it. I probably don't own the rights to that. Let's see if it plays. No playing. Ah, yes. So the purpose of this was to be able to shift things up and down and see where they sat on all of these different scales. At the time, I was helping my dad to build a pipe organ, and we were trying to pick a note scale, and this was the method I was using to try to figure out which notes we would be able to play depending on which scale that we picked. Kind of sad that it doesn't work anymore, but what do you expect with these ancient web pages with really specific dependencies on web APIs? Moving on. A long time ago, I was going to build a car with a chainsaw engine, and that never happened. But you can see that I got some distance towards it. There's the chainsaw engine, there's the wheels. It had rubbish suspension. This windscreen wiper motor never worked. But in this project, I was trying to get the steering correct. And I don't think I nailed it here. That is probably not ideal. Anyway, moving on. Okay, this is just a screensaver type deal, I guess. Looks like we can grab individual particles and move them around. It's good fun. I think they just get bigger and bigger until the screen is full. That's satisfying, isn't it? Oh, yes. Yes, look at them squeeze. Nom, 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 nom. We're deleting it. It's going away. Ah, now, here's an interesting idea. The question I had was, what's the minimum number of colors that you can coat an icosahedron with, but still have the pattern be symmetrical and regular and use the same number of each color tile. So in this, you could right click to sort of assign these colors, and it was just a way of manually playing around with that problem. So this is an extended version of the problem where the icosahedron has had one level of subdivision applied. But if we go back, I think this is also the icosahedron with one level of subdivision as far as I can tell. Pretty rubbish. This one actually used to work really well on old slow browsers. It used to draw much more vibrant lines. But because modern browsers are way faster and they just have like different timings and stuff for how they handle events and that, and probably just the canvas drawing APIs have changed a whole bunch. If you move your mouse really slowly across the screen, you get this nice kind of soap bubble tube effect. And that's kind of made by drawing a sort of, I don't know, what would you call it? A diamond blob. A diamond with the two outside corners rounded over, and that just trails behind the mouse according to some formula. But yeah, doesn't work that well these days. Let's have a look at some good fun. This is when I was playing around with Verlet fabrics, Verlet integration of particles connected into a fabric. And I made this wonderful, timeless, jiggly thing which you can grab and flip around, and it's affected by gravity. And it kind of gets crinkled up, which sucks a little bit, but, you know, I like it. That is an old meme. One of the original, the OG memes. Here's another one. This one still works. So the special thing about this one is that these are rendered using WebGL. I think I used the Three.js library to make this work. There's this one QB that goes crazy because it's trying to get to the mouse, and if you go to the edge of the screen, it flips out a little bit. The rest of the QBs are sort of confined to this circular space. Now, if we make this smaller and smaller, we might be able to get them to fill the whole circle. There we go. That one little QB attached to the mouse kind of spoils the effect. Here was the predecessor. This one's a little bit more tame and stable. Something that really annoyed me when I was working on this project were these boxes here that sort of invert into that hourglass shape. Because they're kind of made out of like 4 sticks and then 2 diagonal sticks, it can get twisted around, and then the renderer sort of renders it as the hourglass shape. And I couldn't come up with a way to make it come right. And just very recently, I was watching a video by the maker of Jellycar, and he explained in the most excellent way how to avoid this problem. The upshot is that you try to position a square, like a rigid square, over the top of the average of the position of the squishy square, and then you just put a spring between the rigid square and all the 4 corners. So the rigid square never can turn inside out, and therefore it's always pulling the corners of the squishy square towards the rigid square, and the problem is solved. But anyway, really enjoyed making that. It was such good fun. Let's go to Verlet fabric. So this is nothing too special. It's very similar to the heavy breathing cat. I just thought that the sort of semi-transparent nature of the fabric made it very interesting to look at. Moving right along. Here's one that no longer works. It actually gives a really nasty error message because basically the way it was supposed to work is you would upload a bunch of images. It would use JavaScript to actually process the image binary itself and extract the latitude, longitude from the EXIF metadata, and then it would put pins on the map. And if you clicked a pin, it would highlight the image. But of course, Google now charges for the use of its map in this way. In the good old days, it was free, or maybe it wasn't free, but it was like you had to pay a license to use it commercially, but there was no block from using it freely. Anyway, can't do that now, so it's broken. Moving along. This one's really cool. So this is a fractal which is made using a turtle fractal, basically. So string replacement fractal. Yeah, look that up. I'm not going to explain string replacement fractals here. They have some different names, but basically if you click on one side of the screen, it gets more complex, and if you click on the other, it gets simpler. Here's the Levi C fractal. And this one basically works by putting 90-degree bends into the lines. Sorry, I don't know how this is supposed to work. There we go. Yes. This one's very satisfying because it's quite easy to program this one. And the result is pretty spectacular. That's what it looks like as it gets more and more complex. Probably could have taken this way further. At the time, that used to lag out the browser and get really slow. So it's pretty conservative. Oh, this one's fun. So you increase the number of iterations by clicking on the top or the bottom of the screen. And then you move the mouse left or right to fold it up. Now, the reason for that is you can actually make this fractal using a piece of paper, like a strip of paper. I wish it would fold one fold at a time, but they kind of get mushed together. But yeah, if you there's a certain way of just taking a strip of paper and folding it repeatedly, and then if you open up all your folds so that they're like everywhere that you've folded stays at 90 degrees, you end up with this fractal, and it's called the dragon curve. That's the most iterations that it goes to. What is eased Koch snowflake? This one's kind of special to me because this is going to sound super nerdy. I had an assignment at school where we had to study the properties of the Van Koch snowflake or the Van Koch triangle. So this is basically 3 Van Koch triangle fractals stitched together in a triangle shape to make a full snowflake. Yeah, we had to calculate the surface area because fractals like this have a finite surface area, but an infinite perimeter. Okay, let's have a look at marching squares. Does it still work? Ooh, it does. Oh, and it's just as satisfying as it ever was. So the marching squares algorithm, it's a way of taking a grid of numbers that vary between 0 and 1 and making ISO lines, I guess, where all those values are roughly the same. So the white lines here are sort of highlighting, like if you blurred out all of those red squares with the black squares, where you would find the sort of lines of equivalent redness. And we can change like here we go, the fit. There we go. So if we put it on the tightest fit, the white line is highlighting the edge of the 100% red zone when you blur out the black and the red. And if we put it on loose, we're going to find it goes all the way out to the 100% black line. It's often used in games to make caves and stuff. Very nice. Truncated to either black or red, you get these beautiful 45 degrees. Right, so when I was writing my thesis, I got really interested in word counts, and I thought I would make a thing to do some statistics on the word count of my thesis. So the way this works is it just highlights like throughout the document, like on this page, I was talking about learning BeamCalc, more student used were following page design research. The thesis was traumatic. I don't want to talk about it anymore. This one kind of bummed me out. What this was supposed to do was rotate the hue but it turned out that it wasn't possible. Yeah, so the way I was expecting it to work is that you'd be able to rotate the hue like that. Now that's a pretty cool effect, right? But it turns out that browsers use a simplified matrix multiply based method, which is like way simpler to execute, much faster than this method. Yeah, I don't know. If anyone knows, what gives? Why do browsers use the worst possible hue rotate algorithm? And why has no one noticed? That just looks gross. Okay, let's jump through a couple of these. Nothing special going on here. There's just a sine wave of points, and then this red vertical line. And as you move the red line across, each of the parabolas is drawn where the red line is equidistant to that point. Pretty cool. It's part of an algorithm that would have drawn the Voronoi thingamy. This Voronoi implementation does not use that. I don't remember how this works, but yeah, moving on. So you can draw a Voronoi diagram with some points, which you can add by clicking. Next, this was probably the first thing I ever made with Three.js. I was incredibly proud of myself because I wrote the code that generated that mesh from scratch, and then I even animated it with some displacement and dynamically fed the geometry back into the GPU. This is an implementation of the QuickHull algorithm. It's a very well-known, well-established, widely used algorithm, and it is good fun. Moving on. What have we got here? Ah, the binary keyboard. I remember this. So the way that this works is that there's two buttons here, the 0 or the 1, or I intended it for use with the arrow key. Let's say I want to type the letter capital K. So I would press up on the keyboard, and now it's below the dotted line, so down, and now up, and then down, and then down, and then up. And then 0, 1, 0, 1, 1, 0, I've just typed K. I was very pleased with this at the time as well. Kind of just a novelty. Super Swirl, here's another one that doesn't work so well without the slow old browsers. They used to draw the lines a lot closer together for some reason. It just kind of follows your mouse around, and then there's a Bezier curve. And MetaMaker. Oh, this was kind of cool. So you would just enter your title, description, URL and stuff, and all of this used to be required to get a nice thumbnail on Facebook. Matt smells of egg. Matt, I apologize. I never did end up removing that. So this is a Boids implementation. But one of the Boids has the unfortunate property of actually repelling all other Boids. So whenever it gets near a group of Boids, they all scatter and run away. And I named it after my friend Matt. This was just a earlier Boids implementation. Nothing too special, although I do like the jiggly sort of shape that they take. Makes them kind of look like jellyfish that are really amped up and going for it. More Boids implementations. I don't know why I kept all of these. Well, these are kind of nice. They're kind of squiggly jiggly. Very good. These were good fun. I think actually this original version was a bit nicer because they tended not all to clump up into one ball so quickly. You could get a bit more chaos going on in this version. This one's a bit slow. I'll let that run. I think you get the idea here. It just kind of grows. The best one I ever made was in Flash, but sadly I never managed to really like nail down the parameters to reproduce that in JavaScript. This was about the closest I ever got. Moving on, it's just an earlier implementation of vines. Let's not look at that. And, oh, this one's weird. In this one, you move your mouse and it spawns a vine. It was just a precursor, like a fun little toy that was a precursor to the Vines one. Yeah, that's pretty naff. I don't like that. Wow, I can't believe this is the first thing I ever put here. What this is supposed to be doing is showing that if you properly rotate an involute gear, you basically carve out another involute gear. Here it comes. It's going to close up, and I'm sorry to disappoint you, but it goes on top of itself. It doesn't complete nicely. But, you know, it's kind of cool. And if you take it into GIMP and you do the hue saturation, this is what I'm talking about. You can get some really cool psychedelic animations like this. Okay, so I was talking about beam calc before, so here it is. This is supposed to be a tool for calculating the bending capacity, the moment capacity of a concrete beam. I've totally forgotten how it's all supposed to work. It's very deeply connected to the Australian standards, and this uses some deemed to comply methodology of calculating the capacity. I don't think it has anything to do with the actual capacity of a tested beam, but using this kind of calculation method, you know, it's all about calculating the area of the steel and stuff. You can add top reinforcement of a certain size, and you know, like layers of reinforcement. And it'll tell you your two layers are probably a bit too close together, so you have to move them further apart. So that looks like it could be reasonable. Probably you'd want to just, there we go, N20, and then you're supposed to ignore any of these other bits and pieces. And yeah, there's the force diagram. So if you could show a banana for scale, which I think is important. Yeah, so if I make these beefier, you can see that the area of concrete and the cracking and the, yeah, just the whole force diagram changes and stuff. And then it would show you using MathJax, which still works, which is amazing to me. It would show you what each step of the calculation that you had to do and what the value was. And here it all is. It just lays it all out for you. Substituting in all the known values, blah, 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 blah. Now substituting back, and you end up with 911 kilonewton meters, which is quite strong. Like, that's quite strong. But there were a bunch of checks, so this is probably over-reinforced. So according to Australian Standard 3600, you probably don't want to actually make a beam like this, because it ends up being that the concrete fails way before the steel fails, and that means you can end up with brittle failures, which is not good. You really want the steel to just kind of sag and the whole thing gets cracked up before the concrete just explodes and the whole structure suddenly collapses. Some of these had like documentation filled out. So like, I guess this was, oh, the back button doesn't work. Yeah, this was me wanting to be like, with software, documentation is so great compared with engineering standards. Like, I really want civil engineers to realize what software engineers have as documentation, and then implement that for civil engineering and civil engineering standards. Because, yeah, Australian Standard 3600, whatever it was, is a nightmare to read. Even the worst software documentation I've ever read is so much better than the best engineering documentation I ever read. There were a couple other personal things on there. This was a card I made for my partner when she turned 22. This was another one I made for my partner. So it looks like just a random Boyd simulation. I'll make this a little smaller actually. But if you hold down the mouse, they will suddenly start orbiting the word Kara. Oh, this is one that I made also for Kara. So this one is actually a graph of data which was scraped from the local power distribution company. And it's basically on the left-hand side is the morning, and then midday and afternoon on the right-hand side. And then these are sort of days or weeks, I can't remember. I think each of these is a week where there's like a lump and a big dip in power usage over the weekend. So that's basically what power usage looks like where I live. Collected data for a long time to get this. Very cool university stuff. Okay. Here's a little discovery. So apparently once upon a time I tried to make a text game. Let's do question mark. You think for a bit, you can jump. And maybe let's look around. You see a lily, a tree, a pond, a flower, a rock. Look. Fish. It looks pretty big. You shiver internally at the thought of a swim in the pond. Okay. Swim. You are disemboweled by a fish. Game over. Moving on. Looks like there's a hidden random variant of the one we saw before, except the particles can be destroyed. Oh, here's another interesting one. So this is a word analysis of The Hunger Games, probably the first book. And this is much more interesting than the one about my thesis. So if we click on any given page, spoiler alert, I haven't read it, but I guess could be spoilers. So let's see, about a third of the way into the story, Peter says Arbeen has because to down district had Haymitch never around before good where maybe while through water eyes thing help sinner people both enough girl very although really almost Effie hand Katniss until sure bread remember probably nothing place here. That's what happens about a third of the way through. So Prison Planet by William Dietz. Really enjoyed that book. I think I've read it twice. I'm not sure how much I'd enjoy it reading it again today. Ren Marla had right while off around. Ooh, Blaster. Blaster makes an appearance. Blasters are fun. You can't have sci-fi without a blaster. If you made it this far, thank you very much for watching. This has been EngineerNick.com. It won't be like this next time you look at it. It may actually be down because I have cancelled the hosting service. So it was a fun last hurrah, and now I can move on with my life and make a new website. Bye.